Okay, we are gonna continue from lecture 19, and this time we are gonna modify the pizza game a little bit. Everything is same, exactly same as the previous game, except for the fact that Penny, as well as Barbara, used to have a class at 1 o'clock, 1300. Now, we are going to assume that Barbara still has a class at 1 o'clock. However, Penny does not, which immediately means that if they do not get to any conclusion or agreement at 12:40, previous game, then nobody gets anything. Both of them will get 0. Okay? And if you remember, that is why when Barbara offers Penny almost nothing, 0.001 pizza, Penny say, oh, it's better than nothing, and accept it. Now, Barbara should enter the class at 1300, 1 o'clock. Penny doesn't have to. We know that, if you remember, I assumed the value of the pizza at 1 o'clock would be 30. So, which means if they do not come to any conclusion agreement at 12:40, at 1300, Penny will get the 30 and Barbara will be 0. This changed the whole game. At 12:40, in the previous game where both have to go to the class at 1 o'clock, Barbara offers nothing, almost nothing to Penny. Now, in this game, if Barbara offers anything less than 30, Penny will say no. And then Barbara will get 0 because she has to go to the class without eating anything. So, what would Barbara do in this case? Barbara would offer Penny at least 30. There's no reason to offer Penny more than 30, but at least 30. So, at 12:40, if you remember, the pizza value is 70. So if Barbara offers Penny 30, Barbara will get 40. Knowing that, once again, we are doing the backward induction, coming from the future to the present. So we thought about 1300, 1 o'clock, Penny will get everything 30. Knowing that Barbara offers 30 to Penny at 12:40, as a result, Barbara gets only 40. Knowing that 12:20, Penny has to give Barbara 40 because she's gonna get 40 anyway. If less than 40, Barbara will refuse. So Penny offers 40 to Barbara. As a result, Penny will get 100 because 12:20, the pizza value is 100. Okay, so the conclusion is 12:20, Penny gets 60, Barbara gets 40 in the end. Okay, so what actually happened in this game is everything else is in their mind, Penny's and Barbara's mind, and what we can observe is Penny offers, oh, Barbara, at 12:20, I'll give you 40 and I will have 60. Is it okay? And Barbara said, yes. What is going to be happening? 12:40, 1 o'clock is only in their head. Okay? And this result is different because in the previous game, okay, let's go back there. Barbara and Penny offers Barbara 70. In the Penny said, when both of them have a class at 1 o'clock, Penny will offer Barbara 70, and Penny said, okay, I'll have 30, you got 70. Is it okay? And Barbara said, yes, at 12:20. So, the new game, where Penny does not have a class at 1 o'clock, things changed. At 12:20, instead of Penny 30, Barbara 70, Penny 60, Barbara 40. So we can see the no class at 1 o'clock works for Penny in this case. But as an economist, what is the most important thing? This result is efficient too. Why? In the previous game, the division between Penny and Barbara was 30-70. 30 plus 70, 100. Here, it's 60-40, 60 plus 40, 100. So, in the end, the sum are same. Okay? And the key reason why that is true is they made an agreement. They settled at 12:20, the earliest possible time. Once again, what makes economists sweating in this case is the value of pizza decreases as time passes. So in order to get the efficient result, both Penny and Barbara should resolve their differences as quickly as possible and make an agreement at 12:20. Whether Penny is a class or not, they do that. They make an agreement at 12:20. So that's why we say both are efficient result. Even though Penny and Barbara prefers one over the other. But as a society whole, the sum are same. Okay? If you understand this, you are almost halfway to the real economist. Okay? Now, that is, like interesting stuff maybe, but the real fun is incomplete information game. It's getting more complicated and getting more interesting. In the previous two cases, the results were efficient, both of them. And game theory-wise, why was it so? Both Barbara and Penny knows each other completely. We call that complete information game. Now we move to what is called incomplete information game, which automatically means Penny does not know everything about Barbara, Barbara does not know everything about Penny. Here, I'm going to assume that Barbara does not know everything about Penny. What fact about Penny? Penny may or may not take the law and economics class. So, from Barbara's point of view, Penny and Barbara knows that Barbara is taking the law and economics class. So, she has to leave before 1 o'clock, 1300. However, Barbara does not know whether Penny takes a class or not. Of course, Penny knows that, okay? But problem is, Penny can lie, which means Penny takes a class, but Penny may say, oh, I am not taking the class. Or Penny is not taking the class, Penny say, oh, I take the class. But in the previous two examples, in which case number 1, Penny takes a class, case number 2, Penny does not take the class. When did Penny get a better deal? When Penny takes the class, her share would be 30 only. But when Penny does not take the class, she got 60. So there is no incentive that when Penny does not take the class and pretend to take the class, then she will only shrink her portion. On the other hand, when she takes a class, she has a strong incentive to lie that, oh, I'm not taking the class. Because when Barbara believes that, Barbara would be willing to give Penny 60 instead of 30. Okay, think about this. Penny offers, say that, oh, Barbara, I know you are taking law and economics class at 1 o'clock. sorry for you, but I'm not taking the class. That can be true or not, but if Barbara believes in it, then when Penny said, okay, at 12:20, I'm going to give you 40 and I'm going to keep the 60, bigger portion. If Barbara believed that, Barbara said, oh my God, why Penny is not taking the 1 o'clock class? And she says, yes. If Penny really is not taking the class, okay, that is maybe fair. But if Penny actually take the class and lied, then Penny surprisingly, shockingly improved her portion from 30 to 60, while Barbara lose from 70 to 40. Okay? That is the fun part about negotiation. You can lie and you can benefit. And believe or not, in real life, people really do that. Okay? So, when Penny lies, and if you are a Barbara at 12:40, and Penny says, come on, I'm not taking a class. So at 1 o'clock, if you offer me less than 30, I refuse. So give me 30. If you're a Barbara and you are suspicious whether Penny might have a class at 1 o'clock, would you offer Penny 0 or 30? If you believe Penny has a class at 1 o'clock, you should offer Penny 0 and you keep 70. But if you believe Penny does not have a class, then if you offer 0, Penny would certainly refuse and you will get nothing. If you worry about that, if as a Barbara, you offer Penny 30 and you got 40, then Penny will certainly accept that. And you can keep at least 40. Okay? So this is kind of game of chicken. Like if Barbara is strong in her belief and take the risk, she'll offer Penny 0 and keep 70. She may get 70 or she may get 0. But if Barbara is weak-hearted, then she's going to give Penny 30 and she's going to keep 40. Then she will certainly get 40. What would you do? Think about one possible scenario. If Penny offers Barbara 40 at 12:20,